Welcome again to the continuation of the topic set. This day we'll be discussing operations in set. What does operations in set mean? It simply means what and what do we do in set. Now, there are a lot of things we do in set. 1. Union of set. 2. Intersection of set. 3. We also do complement of set. 4. We also do Cartesian product of set. 5. We also do difference of set. 6. We also do symmetric difference of set. 7. We also do inverse of a relation. And 8. We also do composition of relation. Okay, now want to see the meaning of this one after the other. Union of set. What does it mean? It means joining together of elements in the two or more given sets. This union of sets is denoted with U. So, take for instance, A equals to 2, 3, 4. Then set B equal to A, B, C. And they say find A union B. A union B will be giving you what? Join the elements together. 2, 3, 4, A, B, C. Note that if you are asked to get B union A, it simply means join elements B and A together. That will be giving you A, B, C, 2, 3, 4. Remember that because we say the position of the elements are not important as far as they are put in curly brackets. It simply means that what you see here, can you see the elements here? Yes, irrespective of their position. So you say these two sets are equal. In other words, we say union of two sets are commutative. We now say that A union B is equal to B union A. This is commutative law. Commutative law. Because we have seen that it is true here. Then we go to intersection of sets. In intersection of sets, it is denoted with small letter n. So, what does intersection of set mean? It simply means write down the elements that the two given sets have in common. That simply means if they say set A equals to, what is set A? 1, 2, 3, 4. And they say set B equals to 1, 2, 4, 6. And they say set C equals to 5 and 6. They say find I, A intersection B, I, A intersection C. And they can also say find I, A intersection B intersection C. See what it simply means. A intersection B. You ask yourself, what does set A and set B, what do they have in common? Set A have 2, 4, set B have 2, 4. You say the answer is 2, 4. Then you come again, A intersection C. A intersection C. What do A and C have in common? you say they have A have 1, 2, 3, 4, C have 5 and 6. They don't have any element in common. So you say empty set, or you put it this way. Then when they say A intersection B intersection C, what do A, B, C have in common? A have 1, B does it have 1? No. C does it have 1? No. A have 2, B have 2, but C do not have 2. A have 3, B do not have 3, C do not have 3. A have 4, B do not have 4. Okay, B have 4 and C do not have 4. So you say they have nothing in common. So you say empty set, or you put it this way. Now, note that if they ask you get IV, B intersection A. What is B intersection A? It simply means, what does B and A have in common? They have 2, they have 4, you say 2, 4. Remember, when we say A intersection B, we have 2 and 4. B intersection A, we have 2 and 4. It simply means that A intersection B is equal to B intersection A. That is, intersection of two sets are commutative. So when you say A intersection B, it's certain as B intersection A. That is it. So we go to complement of set. What does complement mean? Complement simply means write down elements you see in universal set, but they are not in the main set. I repeat, write down the elements you see in universal set, but they are not in the given subset. Okay. Given universal set equals to 1, 2, 3, 4. And given set A equals to 3. And this is called A complement, or A complement this way. It simply means, what element can you see in the universal set, but you cannot see it in the given set? You say A complement equals to, I can see 1 in universal set. Can I see 1 in subset A? No. I write 1. I can see 2. I can see 2. No. I can see 3. I can see 3. I will not write it. I can see 4. Can I see 4? No. So I'll say 1, 4. This is A complement 1, 4. So this is how to write complement of a given set. We go to Cartesian product of set. Cartesian product of set. What do we mean Cartesian product of set? It simply means that when you are given set A equals to A, B, C, and set B equals to 1, 2, 3. Then the implication is that A cross B is equal to, use the first element to multiply each of the elements this way. A, 1, B, 1, C, 1. Then use B to multiply the second element, the second set. You say B, 1, B, 2, B, 3. Then use the third element to multiply. C, 1, C, 2, C, 3. Then what of B cross A? You now say, use the first element to multiply. 1, A, 1, B, 1, C. Use the second element to multiply. 2, A, 2, B, 2, C. Use the third element to multiply. 3, A, 3, B, 3, C. So we say that this is A cross B and this is B cross A. Then what you now do is that you ask yourself, set A cross B and B cross A, are they equal? No, they are not equal. Why? It's because, as I said before, A comma 1 is not the same thing as A comma 1. This is using a curly bracket and this is using an open bracket. Or this is not equal to this. A comma 1 is not also equal to 1 comma A. But when you say A comma 1, you say is equal to 1 comma A. Why? Because you use curly bracket to present it. Because if not use curly bracket to present this one, you say they are not equal. Because this one curly bracket, this one not curly bracket, you say they are not what? Equal. So what you now say is that because 1 comma A is not the same thing as A comma 1, 1 comma B is not the same thing as B comma 1, 1 comma C is not the same thing as C comma 1, you say that cross product of two sets or Cartesian product of two sets, Cartesian product of two sets are not commutative. Not commutative. Not commutative. So they do not obey commutative law. That is, this one is not equal to this one. That is about Cartesian product of sets. Please subscribe to my YouTube channel as you enjoy this topic, and don't forget to like the video. See you in the continuation of operation of sets. Thanks.
My God, they make this guy make enough.